Nazywam się Michał Głowiński, zajmuję się czujnikami w firmie CTS Systems. Dzisiaj będę miał przyjemność poprowadzenia webinaru na temat czujników do badań i monitorowania w przemyśle morskim, lotniczym oraz obronnym. Na wstępie chciałbym jeszcze przedstawić firmy, z którymi współpracujemy. Głównie należy tutaj wyróżnić firmę PCB Piezotronics oraz The Modal Shop, którzy zajmują się wszelkiego rodzaju czujnikami oraz kalibratorami drgań, młotkami modalnymi, a także firmy takie jak Politek, producent wibrometrów laserowych, firmę Siemens, której jesteśmy partnerem dostarczającą rozwiązania symulacyjne, czy też urządzenia do akwizycji danych, firmę FLIR zajmującą się kamerami termowizyjnymi, także wiele innych. Mottem naszej firmy jest wychodzenie naprzeciw potrzebom naszych klientów i dostarczanie im nowoczesnych rozwiązań pomiarowych i oprogramowań inżynierskich. Jako ECTS System staramy się osobiście weryfikować specyfikację i funkcjonalność, dzięki czemu możemy być pewni oferowanych przez nas produktów. I to jest właśnie to, co wyróżnia nas na tle innych firm. Nie jesteśmy wyłącznie firmą zajmującą się sprzedażą produktów. Oferujemy również usługi takie jak pomiary, testy wibracyjne, kalibrację zakupionych czujników, także naprawy gwarancyjne czy pogwarancyjne, ale przede wszystkim oferujemy profesjonalne wsparcie dla klienta. Dzięki naszej doświadczonej kadrze inżynierskiej jesteśmy w stanie szybko i sprawnie udzielić należytego wsparcia we wszelkich możliwych problemach. Dysponujemy szeroką siatką kontaktów, która została wypracowana przez lata doświadczeń w branży. Przez znajomość rynku jesteśmy w stanie doradzić Państwu w wielu obszarach, nawet w tych, którymi się bezpośrednio nie zajmujemy. Natomiast jesteśmy w stanie skontaktować się z innymi firmami, z którymi współpracujemy. Oferujemy także wypożyczenie sprzętu. Także jeżeli chcieliby Państwo przeprowadzić testy sprzętu, powiedzmy na przykład przez 2 tygodnie czy przez miesiąc, to czasami lepiej po prostu wypożyczyć taki sprzęt zamiast inwestować i kupować go. Także teraz oddaję głos specjaliście z PCB Piezotronics, doktorowi inżynierowi Carmine Salzano. Bardzo proszę. Carmine, you can start now.
Different applications in aerospace and defense. Today we'll focus on defense, especially underwater vibration and pressure sensor. In particular, defense shock defense application are also related with shock and blast, where we use pressure accelerometers for shock and pressure sensor also. One of the part of the defense can be considered the Navy in terms of military vessels, but this application is an overview of application can be applicable also for the civil naval civil vessels. We try to call vessels in a very generic word because the application is very different, and I think we can divide in 2 parts. One sensor for testing, the other one sensor for monitoring. The sensor for monitoring, for testing is a very different application. Of course, these are just the application we can serve with our sensor, not all the type of application, as well as also the monitoring. These are few monitoring applications we can serve with our sensor. One particular application I would like to mention, because we will not treat in the future, in the rest of the presentation, is the comfort. Comfort is a typical test for passenger ship, like a large cruise ship, and acoustic are obviously one of the main parameters. But here is also to note, important to note that some accelerometer for measurement on seats and also breakers useful for measuring the comfort or level of vibration. That level of vibration could also be largely measurement as a motion. For instance, the motion sickness typical of some people on the ships Also important for testing of ship behavior of slow motion. In fact, a test not listed here is a ship motion test or slow motion test. In naval engineering, a ship motion test is a hydrodynamic test performed with a ship model for purpose of designing and a new life sites, for instance, a ship, and in a ship designed to improve the performance at sea. And in fact, tests are performed in a dedicated basin. One of the important key studies are acoustic, as already mentioned. Acoustic is an important field for ship design, both for commercial passenger and also for military use, because the acoustic tests are very important, obviously, for comfort of passengers in a passenger ship. But for military use, it's important to maintain, to keep the stealth capability or invisibility. Noise and vibration are also closely related to phenomena based on physics studies. And the ship propulsion in a global sense is a most important source of noise. And the propeller, I would say, is the individual source of greatest influence of weight in the total. Outside propulsion, also we can mention generator, air conditioning is also a very important noise source. Among other kind of tests or sensor, we will see some tests for pressure sensor especially. You can see here some test sensor from microphones to the pressure sensor, which after all, they measure all vibration, acoustic, and the accelerometer measuring vibration, of course, strictly phenomena. So for acoustics, not needed only to measure with the microphones and with the pressure sensor, but also vibration. Now, focusing on the acoustic test sensor, here we can see the test the test type is location, like interior, and the correspondent class of sensor used. Interior, of course, we use microphone because we, as I already mentioned, we want to measure the sound inside any vessel. Commercial, military, we need to keep under control the sound. So a condenser precision microphone is the typical type of sensor used. Now, moving to the exterior surface, we can have in surface or deep water. In surface, you can see the green. We typically can use a sensor which is more robust than microphone, less sensitive, but you can use a flash mounted, for instance. And this is very popular for naval studies on, for instance, on prototypes or models and measuring flash mounted. Finally, for deep water, we can, everybody knows the hydrophones. The other phones so far is the only type of sensor not manufactured yet by PCB. But we have many type of sensor in underwater, using for underwater, deep underwater also. Sensor, which means pressure sensor or accelerometer and force sensor. And we will see the second part, how we test. Here you can see three pictures, rather interesting. These are kind of rendering of design of three types of microphones. One is the flat microphones. The flat microphone is this one. This is just a rubber. This microphone is, I hope you can see my mouse here. This microphone is flat, is very useful to just screw quickly on a surface to measure the sound on a surface. This is very useful for internal surfaces to measure the microphone, the sound in a surface internal, of course, even if this microphone is kind of resistant to the splash water. However, this microphone on the middle is a condenser precision microphone. And of course, in my many webinars, I can explain the technology behind this sensor. This is a typical for a measurement of sound pressure level in air, inside the vessel, of course. However, there's another one which is the very interesting, which is the sensor we use for particular application where we have a harsh environment. Harsh environment are environment where we have a lot of water, splash water, oil, dust. Typical, you can find in the machinery engine room of the vessel. In this case, if you want to measure close to machinery, you have a very humid environment, splash of water, dust, and oil spray. In this case, you can use this microphone, which has a double pad, is IP55 certified. The typical microphone for precision measurement are this one, is just a little chart for selection. And of course, we have a different type of field, pressure field, random, so for diffuse field and free field. Different type of field, different type of sites on microphone in terms of frequency range and dynamic range. So in order to select the proper sensor, I invite you to one of the webinar for acoustic. Shock is another test which is not very common, but it's a kind of test performed on a military ship, because sometimes you want to measure the strength of the vessel under impact. For instance, when it's hit by a torpedo or any other close vicinity offense stuff. In this case, you want to measure the shock resistance of the vessel, different points. And here, these are two technologies state of the art for shock test up to 100,000 G or even 200,000 G between PCB and a DECO. The ship model test basing plays, however, an important role for the basic design stage of a pre-built ship. So the very large object like a floating ship can be made in a smaller scale in order to predict the behavior and study in a model basin. So we can have a hydrodynamic test facility, we have a water tunnel for experiment, and some of the tests included the propeller test, of course, where we want to also check against the cavitation. And we can see here some selection of dedicated sensor, pressure sensor for this application. In particular, you can see the 103 M49 here for the, I would say, basin test mounted flash is also water resistant sensor. This one was also miniature sensor. And at the end, I will show I will close the presentation. I will show all these sensors at the end in my hand so you can see the size of the sensor. These are two particular sensors. These are pressure sensor for current output. These are not ICP, but current. This is something particular when you have a very deep application for high noise, where you need a current output to decrease the noise. So completely different technology in terms of electrical board. The two sensors I found simply on the web, which are part of papers dedicated, so you can easily find many applications on the web with our PCB pressure sensor. And this one is the sensor I already mentioned to you. This sensor is one used for naval study, flash mounted, can be exposed to the water, just a part of sensitive area. Also, this sensor is hermetic. This sensor is completely welded. But remember, sensor is mounted flash. And these are very important for both sensors for cavitation study. And these are also because these sensors are very high sensitivity. So which means the range is few PSI, almost the acoustic level, a little bit above. And so very suitable in terms of frequency range and especially dynamic range of pressure to measure the purely dynamic pressure. This is also an important feature we need to clarify. There are different types of technology on the market. In fact, also PCB and a DevCo can offer two types of technology. One is a piezoelectric, like these two sensors, which is a AC couplet, very robust, can be welded, can be underwater. The other one is a piezoresistive, kind of particular sensor measuring static plus dynamic because are DC couplet. On contrary, the ICP piezoelectric are only AC couplet. But this is good because they are not able to measure the high hydrostatic pressure on the water, inside the water, but they are able to measure only the dynamic fluctuation, which is very good to measure in the cavitation studies. So this is a plus outside the ruggedness of this kind of sensors, which are very robust and made also with welded, which means underwater. Then at the second part, as I mentioned, we will see also the how we hydro test some type of sensor. Another application for naval studies are for sure, like any structure, including airplane, is the structural test. For structural tests, we are able to offer all type of sensor outside the data acquisition. Data acquisition is offered by EasyTest, the Siemens, and they are completely compatible with all our sensor. In this case, we have for excitation, we can use impact hammers or shakers, a response typically done with accelerometer, but also one particular sensor is a strain sensor. And this is a unique sensor in the world. It's the only dynamic reusable strain sensor. Inside you have a quartz plate and titanium housing closed. So this sensor is rather robust with ICP output. So you can use the same input stage ICP for strain sensor, for accelerometer, for pressure sensor, for force sensor. Is the only reusable because you can quickly mount with glue it with acetone, and dismount with quickly mount with the sun acrylate, and quickly dismount with acetone, not like foil strain gauge like this one, which are permanently mounted. The drawback, or if you want, the benefits of this sensor is the AC couplet, because ICP piezoelectric, which means it's able to measure even very down to 0 hertz, like 0.03 hertz or 0.5 hertz, to 100 kilohertz, not 0 hertz, not static strain, not to measure static stress. Okay, the after this quick overview of different type of sensor for testing, let's see the to continue the overview of sensor for measuring in the naval sector for the monitoring, which are sensor permanently installed. So we can have a sensor monitoring different machinery, pumps, engines, machinery, and so on. And the main typical application are for sure the diagnostic of pumps, gearbox, and many other machinery. And the other application, I would say, is hull monitoring. And the hull monitoring is the one of the most popular probably application, which make this sensor in a particular way. The hull monitoring is not needed to use only the pressure sensor, but also you can use hundreds of accelerometer on the spread all over the vessel. And this is also very important because which is the question here? The question is that submarine, in this case, is also a vessel, are noise source. So the noise is coming from many type of sources, from machine on board, from noise on the water, flow above the submarines, engine, propeller, as already mentioned, and so on. So the method of detection and identification of noise sources use acoustic invisibility, so pressure sensor, but also especially vibration. Vibration, not only the measuring of the cavitation. Therefore, think about the submarine like a big city making a lot of noise. The goal is to keep noise down. In order to keep noise down, we need to measure this noise, not only with the pressure sensor, in this case, high sensitivity pressure sensor, but also with a accelerometer. And in terms of accelerometer, we have many types of sensors, as I already mentioned to you, and we will see some hydro tested. Here, for pumps and submersible pumps, we can have some particular some particular sensor here, which are like the sensor for monitoring permanently in very easy way the bearing on the bearing support, of course, but also for pump and also underwater sensor. Now we go back to the hull monitoring for a minute, and I already mentioned to you that the hull monitoring is very important. You can see some of the sensor here. Here is a particular case of the sensor for bearing fault detector. However, the other application hull monitoring can use this kind of sensor. This sensor, like this one, is a 355 M73. This is an accelerometer, which is a case isolated, so completely hermetic and also electrically case isolated for, so insensitive to any noise. This sensor is hydro tested up to 600 psi, so you can imagine the deep where it can work, can be mounted in a very deep and work perfectly without any leakage, any problem. The other sensor for pressure, however, also hydro tested, is this sensor, but this sensor is a current output, as I mentioned to you. It's still piezoelectric, but the current output, it means you need a different kind of conditioning. This sensor of, for instance, 50 microampere in terms of output range, and also we can use also many other type of sensor. Typically, for a vibration sensor, the maximum frequency is like 20 kilohertz. It's not like pressure sensor when we measure up to 1 megahertz. The mechanical vibration is limited to in frequency, and there is an excellent paper which maybe you can ask to EasyTest send you. Is on our website, where he explained this sensor, Professor Pat Walter, why it's not need to measure above this level. However, we have only one accelerometer, which is this one, able to measure up to 60 kilohertz. I understand errors, other kind of problems can happen, but we use this sensor because for some particular test in a gear mesh frequency or some high frequency needs application for test and monitoring. Speaking about monitoring, the last slides I would like to share with you is regarding engines for naval. This is a program, frigate programs, where inside we have the engine permanently monitoring with these two type of sensor. Two accelerometer. One is a generic, very popular 628 FO1 for any part of the engine, different points. And for combustion chamber, very hot areas, we have this accelerometer, which is also differentially isolated, of course, with resistance up to 700 degrees Celsius. So this sensor can work in a very hot area, in hot part of the engine. These two sensors, many years now, are permanently monitoring this type of engines mounted on this kind of frigate class. And of course, these are also, we need to mention all the kind of pressure sensor with all the with a particular crystal we developed, which is part of a dedicated seminar, UHT crystal, which is very excellent and give an excellent performance in the very hot areas, especially when the temperature is variation, is a lot during the measurements. These are all pressure sensors, different shape, all with very high temperature resistance. Okay, just to conclude the first part, this is just a little list of my available webinars. So speak with the EasyTest to arrange any specific technology webinar, because today the first part was just an overview of different type of sensor for Navy. Now the second part, however, we will look at specific technology for deep underwater test. So we mentioned the sensor for inside the vessel, for for mounting outside the vessel and surface. Now we will see sensor underwater concept. And concept of underwater is water is only one of the many parameters affecting the sensor. You can see here an accelerometer, and the input you're going to measure is not exactly the output, because it's affected eventually by different environmental factors. I don't have time to go through all these parameters because you can read yourself, but of course I cannot speak for more than 1 hour here. Therefore, I just mentioned that humidity is only one. Humidity of water is only one affecting the performance. So we need to concentrate now how we can deal against the water problems in a sensor. To deal with all these parameters, we developed a dedicated sensor, of course, dedicated technology for from cryogenic or high temperature or underwater and so on. For water resistance, we can divide in two types of application and therefore two types of technology. The first one for general test, not for deep underwater, for any type of test in the automotive, in test and measurement, even naval study. And in the W option, which is waterproof, or IP rating for accelerometer. The other application is deep aerospace and defense, so deep in the water. These are the two type of parts with this part of presentation we will going to see. So the first part is related to the general water resistant, not for deep underwater, not for underwater, but just for water splash, this kind of stuff. In this case, we have two technologies, as I mentioned to you. The first one is a W option, the other one is IP68. The W option is just a matter to make an O-ring here, suitable O-ring to provide the resistance against the water splash. And most of the applications are in this way, which means you have some water splash can go inside the connector and cable and affect the measurement, even in a welded accelerometer, hermetic accelerometer. Therefore, the weak part is this one. And we can protect with a sort of silicone or O-ring and so on. And we can call this option water resistance. The next step for accelerometer especially is the IP68. So any accelerometer which is welded, the problem can be the connector. But we made a particular glass to metal bond connector, and we made also the hermetic connector with the relative cable connecting. So in this case, we have a complete line of IP68 accelerometer. One application is this one example, sorry. These are triaxial miniature accelerometer with the hermetic connector, completely welded, and the connector is also hermetic. Another example is this case isolated, the same type of connector connector hermetic. But now the question is, yes, the sensor is welded, connector is hermetic. What about the relative cable in order to get IP68 certification? Well, this is the cable. It's a cable 4-pin connector because we are speaking about triaxial, and all the line, accelerometer, connector, and cable is line IP68, which means you can use a 1 meter for 4 hours. So this is the second step after the water resistance. An example, IP6055 is this microphone I already mentioned to you. This IP6055, the water pad here, this pad can be easily peel off and use another one when it's full of water. So, and this is just the process, just picture of the certification of the microphone. So very useful to use in, as I mentioned to you already, in a machinery area to measure the sound. And this is IP55 certified, and this is just a couple of pictures in the certification process. Of course, I didn't mention the pressure sensor, because let's go back a little bit. The pressure sensor here, when it's hermetic, when the diaphragm is hermetic, and you mount flash mounted, okay? In this case, the rest of the body of the sensor is not immersed in the water. Just the diaphragm is in the water. But if it's welded, no problem, can be in the water, okay? So this sensor is already water resistant and can be submerged depending on the deep you're going to submerge, okay? So it can resist the water, can be submerged a few, not much deep, and only when the diaphragm is only flash mounted. Then the second part, now we see when we want all the sensor deep underwater. So complete pressure sensor, these two, or accelerometer, these two, completely underwater. In this case, we can either test the sensor, and also we make another kind of test, which is a leak test, which is a sort of test we do also, we perform in the production for the application also for space, for satellite. Well, first of all, we need to understand a little bit the design of accelerometer. Accelerometer basic core of the accelerometer is the crystal stack with the electrodes, the seismic mass, and the clamping ring. So very robust design, especially when design is in shear mode. And this can be welded, and so the sensor is completely hermetic and insensitive to eventually change of the temperature, especially when you use quartz. The other application is the other kind of sensor is pressure sensor, also piezoelectric, also using crystal stack, as you can see here. But now here, the sensor can be welded also. As already mentioned, you can see the sensor mounted the flash. So here can be water, and only the diaphragm is exposed to water and the pressure. The sensor under unwanted parameter in this case is the vibration, and how you can take into account the vibration here. The vibration is an unwanted parameter. Therefore, we built inside a kind of accelerometer to compensate against vibration, because pressure is what we want to measure. A particular pressure sensor is this deep underwater sensor used for explosion. The crystal here is not quartz or ceramic, it's tourmaline. Tourmaline because an excellent hydrostatic pressure response, and also is omnidirectional. And this is the reason why we use this kind of sensor for deep blast underwater. In fact, this sensor can work up to 1000 psi. Now, let's see how we test the sensor. First of all, we see the leak test. This is a gross test to check the output of the particle up to 10 and minus 3 cc per second. We put in an oven, 100 degrees Celsius. This is a fluorine earth inside this kind of oven. And we can see by eyes the drops coming outside the sensor. If drops come outside, of course, the test is failed. But this is a gross test. For a more fine test, we use the helium leak. So we put the sensor inside a fluorine earth, inside a mass spectrometer, and we pressurize in helium. So we are able to verify in this way up to 10 and minus 8 cc per second. So very, very deep test for hermeticity of sensor and connector. And of course, we have a third case, which is a sniffing test, where we have this kind of electronic nose where we can sniff around the sensor and connector to check it out if any problem. The other problem, of course, is the cable. Cable is very important, and in order to prevent axial flow of water, if the cable outer sheet is cut, there are various degree of acceptance tests that can be performed on the cable to find the effectiveness of water blocking compound according to standard. You can see the water blocking. Another reason I would say is not only the water inlet, but also another reason is important to provide the crash resistance required to work, especially in the deep, in the specified depth. So two reasons to make this design of water blocking in the cable. And of course, the material can be, for thermosetting material, should be useful to be attached to the rest of the body of the sensor. Here we can see some poor cable connection, typically in the form of intermittent bias voltage of sensor, like 0 volt, of course, is shorted. 30 volt is open circuit. And here we can see the contamination by salt water on the conductor. So important to pay attention on the water for underwater use. Finally, the last test we perform is the most demanding, is the hydro test. So hydro testing is very important to ensure the successful performance in operating depth. So this test verified the water block cable and the sensor, including wiring for overmolded. So the sensor we call unit under test. We put inside this vessel here, this hydraulic pipe, and then we fill with the water. We wait and stabilize the temperature, of course, and then we slowly increase the pressure through the flange. We increase the pressure and until the desired pressure, like for instance 300 psi or 600 psi also we test. And during this process, we also check we monitoring the bias voltage, the capacitance, and the continuity. So in this way, we hydro test our sensor. And now, finally, we can see the example for this hydro tested sensor, measuring sensor, tested in this way. First of all, pressure sensor for rapid fluctuation. It can be used not only for cavitation, but also for deep underwater. And the sensitivity is rather high. You can see 50 psi for this sensor, which is hydro tested to 600 psi. And it's also miniature sensor. A particular water test is this one, which I will show you in a moment when I will open my camera at the end of the presentation. And this is a tourmaline underwater for blast application underwater. For vibration, also we have some juridic water resistance sensor and hydro tested. You can see 600 psi hydro tested, but this one is 500 psi ICP. So with this sensor is single axis, and then also we have the triaxial sensor, also cases related, etc., with water resistance. Finally, the force sensor for some force application deep underwater, because this sensor is a dynamic force sensor, so measure force in the deep up to 600 psi static pressure, because we are not measuring this level of course, but we are resistant. Okay, I finished my presentation, and I would like to just conclude opening. I think everything's fine, right?
Okay, it's excellent presentation. Thank you.
Okay, I would like to show you sensor, which I mentioned to you. I hope you can see the camera in a big way. I don't know. Let me close sharing so you can see better my camera probably. This, I hope you can see, I guess, right? Is the flat microphone. The microphone, this one, with the little water resistance. So you can mount this sensor with the flat in any surface. If this is surface, you can mount this way. You can see, and you measure you can just glue quickly with a double-sided tape, and you can mount the pressure, and especially the sound in a surface. However, if you want to measure as I mentioned to the IP55 microphone for water splash, this is the sensor, and this is the only microphone you can open, the other one not. And this is the pad you can see. This pad is when it's full of water, you can simply peel off. And this is IP55 certified. Then we move to the very small sensor, which is the sensor, the accelerometer working up to 60 kilohertz. And now we move to another accelerometer, which is the one that I mentioned to you. No worries, 500 G resistance. The axle with the water, which means water resistant, and the IP68 line, because you can see the very robust 4-pin connector here, and using with the relative cable. The strain sensor is this one, and you can see how small is it, this sensor. You can glue it simply on a surface with the cyanoacrylate, same sensor, same glue used for a accelerometer, and can dismount quickly. And the output is ICP. Pressure sensor, now we move. This is the one I mentioned to you. You can use on a model, mounted flash like this way, flash, this sensitive area, and this is useful for naval study models. So that's why it's such a small sensor, like also this one. You can see the diaphragm of this sensor, how small is it? It's a piezoelectric, but it's ICP. You can see how small is it? Mounted flash, also this sensor. However, for the welded, the sensor is this one, 106, mounted also flash, and is completely welded, as you can see. And finally, the most performing one, the tourmaline sensor for blast underwater test at any depth. Okay, sorry to be so quick, and I'm waiting for your question. Thank you very much.
Także zapraszam Państwa wszystkich do zadawania pytań naszemu ekspertowi. Myślę, że to najciekawsza część, kiedy można właśnie samemu zapytać się o trapiące problemy i zastosowania.
You can ask also in Polish, and then Mikael will translate. No problem.
Yes, of course.
Or you can write in the chat. You can unmute. It's up to you. Normally, when I make the seminar, not the webinar, I used to say, if no questions, everything's clear or nothing is clear. I hope so, the first one.
Okay, we have first question.
Yes.
It's about MEMS accelerometer
Yes.
without cable. And maybe PCB have solution for it.
Why in particular you want to, let me explain. We manufacture the MEMS, the ICP with even some not integral cable, but the question of the piezoresistive is not the capability of PCB, is the cable for piezo, for shock you have ICP, ICP technology and MEMS piezoresistive technology. The MEMS piezoresistive is a kind of particular application, such a treat by care, because it's true that you can measure DC coupler, but the cable length in a Wheatstone bridge, 4-wire full bridge, will affect your measurement a lot, which means that when you use more than, I'll say, 3 meters, you can have a cable. The problem is the cable in general for any piezoresistive cable length. For shock, however, there is an additional problem. Is the connector. If you can see any sensor, right? I can show also the shock accelerometer, okay? And I'll explain why we don't manufacture the shock sensor with the connector, but with the integral cable. Because if you have a connector here, this part will move, okay? Inside the connector, you can have a little movement, and this affects your measurements. So very important in a shock test, use integral cable and tape down the cable. That's the reason why we don't use the MEMS with the or for shock, especially because of other MEMS. Of course, we have MEMS capacity MEMS with the low G with the connector, no problem, because it's low G, it's not for shock. But for IG shock, we talk about 60,000 G. Of course, the movement inside the connector can affect the measurements. Therefore, we manufacture with the integral cable. I don't know why you want you need the one with the connector. Of course, in reality, there is one with the connector, okay, if you want. But this is the very small one. This one. This sensor is for printer circuit board. You can solder on the printer circuit board, especially for fuse application and so on, and then you can build yourself the wiring. If you want to call connector, this is not really a connector. Again, is a permanently wiring.
Okay. Thank you for explanation. Czy Panie Leszku, czy może chodziło Panu o takie bezprzewodowe po prostu rozwiązania, na przykład sorry, Carmine, it's about wireless MEMS accelerometer.
Sorry. Wireless MEMS, well, in terms of sensor, we have the only sensor wireless we manufacture is for permanent monitoring.
It can be other MEMS even, so...
Yeah, but the problem of MEMS, when you use low G MEMS, there's no problem to could be manufactured, okay? You can find on the market, and there is. The problem when you talk about high frequency sensor, MEMS, in this case, when you transmit such high frequency, It's not easy to transmit in a high fidelity way. Therefore, the manufacturing sensor we have, a wireless, which Michael, right, in IMI division, you can send the link to or maybe I can show you. This sensor we call ECO is for permanent monitoring of machinery, even if to 1 kilometers of distance, 1 mile of distance transmission. Is not a MEMS, but eventually a MEMS can be manufactured also for short frequency, for low frequency, not for high frequency, where the problem is still a kind of big problem to transmit high frequency in a very high fidelity way. And especially the size of the sensor become very big. In fact, the size of this sensor we manufacture, which is the only wireless accelerometer we have, is such big. So good for big machinery monitoring, not good for test. You can imagine sensor like this one, like this pressure sensor, if you want to make wireless. It's not easy.
Okay, thank you. Panie Leszku, już przeczytam. Okay, Carmin, Mr. Leszek wants to know if he can put it on the surface without cable, and the other, I think, acquisition device will take the data from it.
Inside the vessel, outside the vessel?
I think that the sensor inside.
Inside. Okay, there's no problem because there's no water. You can mount any sensor, any pressure sensor, any accelerometer, no problem. And yes, you can. I guess you can use it for monitoring. You can use any sensor on the interior surface. I already mentioned to you, for instance, a microphone or any accelerometer. That's no problem. The problem is when you touch the water outside, then we need a particular hydro test sensor. But for interior surface, you can use any sensor, any of our sensor, like microphone, pressure sensor, a micro accelerometer, and so on. The way to mount, I'm here. You can ask me anything.
Tak, także mam nadzieję, że tak, rozwialiśmy wątpliwości pana Leszka. I think we have another question about, let me check, active hydrophones.
Yes, unfortunately, I already mentioned to you, we do not manufacture yet, because we design and manufacture and sell what we manufacture, and we are able to manufacture. Today, we didn't move yet to the hydrophone. That's the only missing sensor we have in our catalog for underwater. We do have, I already mentioned to you, I already show you the sensor for deep underwater, pressure sensor for deep underwater, but they cannot be as active mic hydrophones. They're not transmitting or receiving, unfortunately. We don't have yet.
Okay, it's clear. Anyone have question for our expert? Someone is writing. Okay, we have a question about, I think it's bandwidth for cable model 003.
Mm-hmm. The 003, there's no problem. The 003 has a certain capacitance, okay, like if I remember 58 picofarad per minute, something like that. Then the problem is a physics, right? The longer the cable, the higher is the total capacitance. This total capacitance, if you talk about an accelerometer, piezoelectric accelerometer, no problem, because easily you can measure, I don't know, you can calculate, because we have a plot on our website. Let me go to our website. You can see we have a plot where you can go to measure, for instance, model shop cable calculator. I hope you can see my screen, Nico.
Yes.
So what happens?
We can see.
You can type any type of cable, right? and you can see, for instance, 003 cable, okay? You want to achieve, for instance, I don't know, 20 kilohertz is the maximum for an accelerometer, right? Your acquisition uses 20 milliampere, which is the maximum. You can use 1,000 feet cable, okay? So for accelerometer, this is not a problem for accelerometer. For pressure sensor, it is a problem because you want to measure very high frequency, and then your frequency will be physically limited by the length of the cable. Okay, so you can do your exercise on this link of the Mothershop, our company, and you can calculate the maximum length, which is the maximum frequency for your length of the cable. I hope this is your question. I don't know.
Panie Tomaszu, czy to była odpowiedź na Pana pytanie? Jeszcze jakoś ten temat. Okej, it's fine. Dziękujemy bardzo. Zapraszamy jeszcze do kolejnych pytań, jeżeli mają Państwo jakieś wątpliwości.
Did you check all the chat, Michael?
Yes. Okay, I think it's enough.
Anyway, please ask Michael any later questions, and of course I'm in contact with them anytime. I will answer you by email, or we can arrange a webinar, a WebEx, and so on, right?
Yes, we can even arrange an additional meeting. Także jeżeli Państwo będą mieli ochotę umówić się nawet na spotkanie osobiste z Carmine, to jesteśmy w stanie coś takiego zapewnić. Także jeżeli Państwo będą mieli w przyszłości jakieś problemy, których nawet my nie będziemy w stanie jako ECTS rozwiązać, to możemy właśnie skontaktować się z PCB i coś takiego zorganizować. Także jeszcze na zakończenie, mam nadzieję, że widać mój ekran. Chciałem przedstawić możliwości, jeżeli chodzi o usługi pomiarowe i wypożyczenia sprzętu, także właśnie z Modal Shop. Także czujniki, o których Carmine mówił, są możliwe do wypożyczenia i przetestowania, do sprawdzenia właśnie w konkretnych aplikacjach. Także ja Państwu bardzo dziękuję za uwagę. Zostawiam jeszcze na sam koniec ankietę. Bardzo bym prosił o wypełnienie jej i ocenienie, co się podobało, co ewentualnie moglibyśmy poprawić, jakie ewentualnie tematy na przyszłość. A ja ze swojej strony chciałbym podziękować bardzo. Thank you, Carmine, for your time, for excellent presentation and explaining a lot of things. I hope we will have another interesting topic in the future with you.
Yes, I'm always available, Just can ask to you, arrange a WebEx or a call or a webinar. I'm available. Thank you very much, everybody. Have a great day.
Thank you.
Bye-bye.
Dziękujemy wszystkim obecnym na dzisiejszym spotkaniu. Mam nadzieję, że będą Państwo uczestniczyli w przyszłych spotkaniach. Także dziękuję bardzo również za wypełnienie ankiety. Tak, do widzenia, do zobaczenia.